Hello everyone, my name is Bob Johnston. I'm an oceanographer and retired civil servant. I worked as a scientist for the Navy where I coordinated environmental projects. I'd like to acknowledge contributions to this presentation from the Sediment Management Work Group and Sediment Interest Group. So the purpose of making this presentation is help broaden the discussion between site remediation and ecosystem restoration. Cleanup at many contaminated sediment sites can be very costly, time-consuming, and ineffective if larger scale pressures and ecological processes are not adequately addressed by the remedial design. So these case studies are actually trial and error attempts at ecosystem management. And the key information is not so much was the remedy successful, but rather what did we learn when we were trying to manage the ecosystem. So the case studies are real-world applications of developing environmental quality standards, which are the remedial objectives, implementing a remedial actions, and evaluating the effectiveness. These can be major investments at large contaminated sediment sites costing hundreds of millions up to $1 billion per site and spanning many decades. What the data is informing the linkages between sediment quality and protection of biological receptors in the food web and human. I live in Bremerton, Washington, on the Sinclair Inlet. And this slide also shows the location of the Duwamish Waterway Superfund site, the Commencement Bay Superfund site, and the Nisqually Reach, which is a reference area and relatively unindustrialized area of South Puget Sound. Here's the location of the Puget Sound Naval Shipyard in Sinclair Inlet. The Navy has conducted industrial operations in Sinclair Inlet since 1895. There's no buffer between heavy industrial work and the water, so contaminants released by industrial operations that occurred during World War I, World War II, and subsequent wars resulted in the accumulation of contaminants of concern, primarily PCBs and mercury, to unsafe levels in the sediments and fish tissues in Sinclair Inlet. The cleanup consisted of dredging and disposing the most contaminated sediments in a confined aquatic disposal pit that was created in Sinclair Inlet, which was then covered with cleaner material and capped. Other remedial actions included implementing best management practices and continuous process improvement to control and eliminate sources of pollution from industrial operations and stormwater runoff. These images show the industrial waterfront in 1992 and 2013. Industrial work has been transformed by implementing water pollution control best management practices. In the image on the right, extensive use of containments and vastly improved material storage and handling can be observed. This graphic provides examples of BMPs that seek to buffer the industrial work from the adjacent waterway. Successful implementation requires a change in the culture of industrial operations, similar to improved safety procedures, so that work is conducted to minimize the release of pollutants and protect the health of workers as well as the environment. Here's the location of the Duwamish Waterway Superfund site. Now this is a very complex site with many moving parts. There are varying objectives of the partners and collaborators, many diverse stakeholders, so it's very difficult to come up with a ultimate remedy. But it is pretty straightforward to identify egregious sources of contamination that can be eliminated by early actions before the final remedy has been developed. This map shows areas along the Duwamish Waterway where early actions of dredging, capping, and source control were implemented to eliminate sources of contamination and reduce the risk of bioaccumulation. Over the last few decades, remedies selected at contaminated sites have focused on mass removal or the reduction of exposure to sediment-associated contamination to manage human health and ecological risks. However, the linkage between sediment and biota is way more complex than the assumed sediment to biota relationship used to design remedial options. We know that the food web is way more complex and that there are external inputs from stormwater runoff, other point sources, and disturbances from dredging, in-water work, prop wash, storms, and other events. Additionally, contaminants, once within the food web, are continually recycled through the biota. Here are some data from Puget Sound showing trends of English sole concentrations in Sinclair Inlet and Commencement Bay compared to the reference area at Nisqually Reach in South Puget Sound. Since English sole are flatfish that live in close association with the sediment with high site fidelity, their tissue concentrations reflect the exposure occurring at different areas in Puget Sound. The data show spikes in fish tissue concentration that coincide with sediment disruption. Now, sometimes we have to disrupt the sediment in order to implement corrective actions, improve infrastructure, and maintain commercial viability of ports and harbors. However, we should understand that these actions have consequences that are taken into consideration for achieving long-term management goals. Here's the ecological risk assessment framework. That is the guiding framework used under Superfund to assess and remediate contaminated sites. This process includes formulating the problem, conceptual model, analyzing exposure and effects data, and characterizing risks to inform stakeholders and risk managers about remedial options. Here's an adaptive management framework, which is commonly used for coastal and estuarine restoration and salmon recovery projects. This framework is composed of a cyclical series of steps of plan, do, act, check, learn to support a decision-making process in the face of uncertainty. You envision morphing the risk assessment framework with the adaptive management to create an adaptive risk assessment and management framework. This includes the plan, do, act, check cycle with the iterative risk assessment processes to better inform risk management decisions and maintain constant learning dialogue with the stakeholders, as shown here as centrally embedded within the process. This could help improve cleanup and restoration outcomes. For this framework to work, monitoring of key metrics are needed to provide feedback to stakeholders and decision makers. Knowledge about the physical and transport processes necessary to conduct sediment cleanups is also the same information needed for watershed-based assessments like total maximum daily loads. Under the Clean Water Act, implementation of species recovery plans for the Endangered Species Act, and technical support for ecosystem recovery goals for the larger ecosystem, like the Puget Sound and Saley Sea ecosystem, for example. So, successful sediment remedy depends on controlling sources. This is especially true for a place like Puget Sound Naval Shipyard. By controlling sources, by implementing water pollution control BMPs, successful remedies can be implemented. Sediment cleanup is enabling watershed restoration. It doesn't make sense to restore the watershed if sediments are so contaminated that nothing can live there. On the other hand, it also doesn't make sense to spend hundreds of millions of dollars to clean sediment without restoring habitat and repairing ecosystem processes. Revitalizing watersheds and restoring habitats is protecting the sediments. The sediments are downstream of everything that's going on in the watershed. Early actions can make a big difference. Many of the large sediment sites are very complicated with many moving parts. However, if egregious problems can be identified and addressed before the final remedy is selected, significant process. Adaptive management is key and must be informed by data which are used to revise the conceptual model and improve the capacity to manage the ecosystem. And did I mention source control is important? Not just the legacy contaminants from the site, but also from the surrounding watershed, as well as 21st century contaminants like pharmaceuticals, personal care products, plastics, PFAS, PFOA, and other contaminants. So sediment remediation sites are trial and error experiences that can provide valuable insight for ecosystem management. Here's a list of lessons learned that I just covered. And I also think merging the risk assessment and adaptive management frameworks can help improve cleanup and restoration outcomes. You can access this QR code or link to get the references in the Zotero library. Thank you very much.